Hello, I'm Marcus Woodson, and this is my course, JavaScript Generators and Iterators. We're going to be learning all about iterators, iterables, and generators. All of these features have been added to ECMAScript version 6, or just ES 2015 as it's more commonly called. As you'll see throughout this course, JavaScript now gives us new data structures and methods for natively dealing with their data, and iterating through data is not a new concept. For example, let's think about a loop. We use loops all the time to iterate over data. In a loop, we generally are iterating over each element within an array and doing something with each value. For loops and for each loops are all you need for most situations. If you ever needed to stop iteration, that's possible by using a break keyword. This essentially stops the iteration, but there's no easy way to start it back up at a specific position. Sure, you can save the index and create a new array with the rest of the elements you haven't iterated over yet, but that's a bit more complicated and adds a lot of extra logic. What if instead you just wanted to pause the iteration process and have the ability to unpause or resume the iteration whenever you wanted? This is what iterators can do. What are we going to learn in this module? In this module, we are going to talk about how an iterator differs from a standard loop in JavaScript. We'll also go over what an iterable is and what built-in iterables are available to us, like arrays, strings, and new data structures like maps and sets. We'll talk about creating iterators from built-in iterables using the new primitive symbol. Finally, we'll go over creating custom iterators with custom iteration logic. So what defines an iterator? Well, technically, an iterator is any object that implements the iterator protocol by having a next method that returns a value property and a done property. The value property can be anything really, but the done property is a Boolean which resolves to false when the iteration should stop. I could define a function here that creates a basic iterator that will run until a value is reached. If you haven't already, visit Code Sandbox, CodePen, or JSPen and follow along. Feel free to pause this clip until you're ready. I'll have two parameters, start and finish, which are both numbers. I'll define an index, which begins at the starting number, and an iteration count starting at 0. Now, as I mentioned before, an object needs to have a next method that returns a value property and a done property. So I'm going to define and return a next method here, which will check to see if the iteration count is still less than the in number. And if it is, I'll increment the count and return the count as the value property while setting done to false, since we still have not met the end yet. If the iteration count equals the end number, however, we set done to true. Let's create a variable to hold our iterator and start iteration by calling next right away. Now I'll start a while loop that continues to call next until the done property equals true. This done property works as an escape hatch in this loop. Without it, the loop would be infinite, and nobody needs that. Something that should be noted here is that iterators are lazy, meaning they are not going to do any work until you tell them to. This can be a huge performance benefit. In our example, we are just incrementing a number by 1 on each iteration. But imagine if you were doing something more complex like compressing files or performing complex computations. Having the ability to pause at each iteration means you could break up the work in a more manageable way. Here you can see each value console logging until done is true. This is a basic example of creating a custom iterator. I don't think you should create iterators like this, as there is no way to know that this object is an iterator. What you should do is create iterators from iterable objects. However, what is an iterable? Before I answer that question, I would like to introduce you to console log my food. Console Log My Food is a CLI-based application that we're going to work on throughout this course. Let me paint you a scenario. Your manager comes up to you and says, "We are implementing a new health initiative here at the company. The head of HR has asked me if we had any engineers with enough bandwidth to help build an application. I told them I know the perfect individual. That's you. This application needs to do one thing: allow a user to log what they've eaten. HR plans to offer this application as a free addition to the current benefits package for all employees in the hopes that we can help people get a better understanding of what they are consuming." So throughout this course, we will use what we learn in each module to build Console Log My Food. So let's get started creating this project in VS Code. Create a new folder called Log My Food somewhere on your machine. You can open this directory in VS Code by either typing code log my food, or if you've already moved into that directory, code period. Or if you don't have your VS Code set up with Bash, just open VS Code, then File, Open, and choose the Log My Food directory. Now that we are in the editor, let's get it ready to use npm packages. Open the terminal and run npm init. You can press enter through these prompts. We really want to get a package.json in place so that we can install libraries later. Next, create a file named index.js, which will hold our application logic. We'll want to add a comment at the top of the file that lets the computer know that we want to execute this file with Node. So type out #/user/bin/env node. If you don't already have Node installed, please do so using Homebrew if you're on a Mac, or just visit nodejs.org and download it there. Next, we need to make this file executable. So in the terminal, again, type out chmod +x./index.js. Now we can execute the file from the command line. If you are on a Windows machine, you won't have a chmod command to run, as this works in Unix shells only, like Bash, for example. If you are running Windows 10, however, you can install a Bash shell. You can then run these same commands that I'm doing in this course on your Windows machine. If you don't have Windows 10, you will still need to install Node, but you can skip the chmod command, and every time you want to run the file, you'll add the Node command before the file name. In the next clip, we'll talk more about some of the built-in iterables available, and how we can create iterators using the symbol.iterator method available on all Iterables. What exactly is an iterable in the JavaScript language? Well, without looking at any official definitions, I would imagine that it was an object that allows iteration of itself. Some type of array loop is what I would think of first, since that's precisely what we are doing, iterating over the elements in an array. If you thought the same thing, then we are both partially correct. An array is a built-in iterable. However, they aren't the only iterables available, and there is more to being able to loop over an object that makes it an iterable. Specifically, for an object to be an iterable, it must implement the iterator method, meaning that the object must have a property with a symbol.iterator key. Let me say that again. For an object to be an iterable, it must implement the iterator method, meaning that the object must have a property with a symbol.iterator key. The symbol.iterator is what JavaScript calls a well-known symbol, and its job is to specify the default iterator for an object. Now, this may sound a little new and abstract at first, but you've most likely used an iterator without even knowing it. Have you ever used a for-of loop? If you answered yes, then you have experience with an object that has a symbol.iterator key built in, or a built-in iterable. The for-of loop only works with iterable objects. The for-of loop should not be confused with a for-in loop. The for-of loop iterates over the values of an iterable, like we'll see in this next example. A for-in loop, however, only iterates over an object's enumerable properties. For example, if you're using a for-in loop on an object, that would iterate over the keys of that object, since the keys are the enumerable properties. Every time we call it.next, we are iterating one step at a time, printing the collection's next value to the console until we are done iterating. In this example, the 5th time we call it.next will let us know that there are no more values since the done property will be true. We can also do this with other built-in iterables. Let's try the same example using a map. Create a variable called map, set it to a new map, then use set to add a few keys and values. Again, let's create an iterator, map iterator, using the symbol.iterator method available on the map structure. Print out an iteration, and you will see the key value pair as an array on each next call. When you set a key and a value in a map, they are stored as an array of key value. If you were to use a for-of loop over a map, you'll see what I mean. You can see the connection between the symbol.iterator method and the next call on the iterator that is produced. For-of loops are using the symbol.iterator method under the hood and returning the value of the next call on each iteration. We can run this same example using a set as well. Create a new set called mySet. I'll add 2 values to my set. Create an iterator with symbol.iterator. Logging the set iterator's next call shows us each value. This behavior is very close to the array-based example. Finally, a for-of iteration over mySet should work just like an array for-of. You may be wondering, why didn't done evaluate to true when I logged the last value of 6? Why did I have to call it.next again? Well, this is by design and considered a best practice. To see why this is the case, we need to look at how a for-of loop works. Here is the code to iterate over the iterator it that we created earlier. I'll bring in that iterator from earlier here as a reminder. We can use the for-of loop to log the values of the it.next output. We can write the equivalent functionality just using a standard for loop. After defining the value and result variables, we want to update result on every turn in the loop with it.next, and only do this while result.done is false. You can see this gives us the same output as the for-of loop, and you may see why when the result evaluates to the object with value 6, the done property can't also be true, and we need to call it one more time. If the done property were to be true, that value of 6 would basically be thrown out and never logged. This is why it's a best practice to call it.next one final time after going through each value. It's the default behavior of the for-of loop. If you were to pass a value when done is true in your own custom iterator, it could be confusing and throw someone off while looking at your code. I think it's time we start adding some functionality to our console log my food app. We need to be able to run the app from the command line, have the app ask the user what food or drink they have eaten, and how much did they eat. Then we'd like to show the user how many calories they've consumed. We have a few things here to set up, including the database of food items and the code to prompt the user in the terminal. Let's start with the prompt. Go ahead and open up the console log my food project and open index.js. To deal with prompts, we're going to use the readline node module. From the node documentation, the readline module provides an interface for reading data from a readable stream, such as process standard in, one line at a time. We're going to instantiate a readline process where our input will be standard in and output will be standard out. This means we're taking input from the terminal and printing any output back to the terminal. Now let's use the readline question method, which takes a string as its first parameter and a callback. The parameter that is passed to the callback will be the input received from the user. Let's log out the message "you have entered," then whatever input the user entered. We can end this program by calling readline.close. So for now, let's just have this simple program that we'll build off of. So how do we let the user know how many calories are in their food? And where are we saving their inputs? For this to work, we need some type of database. I recommend following along for this next part, so please feel free to pause while you are downloading and installing packages. We're going to use a tool called JSON Server. This gives us a full fake REST API. We're going to store nutritional information in JSON formatted files and have access to them through REST requests. Let's get this installed using npm install-g JSON server. Or if you prefer to not install this globally, you can instead use npx JSON server once we are ready to start the server. To use JSON server, we really only need a single file, a JSON file that holds our food and user info. I'm going to name the database file db.json. Go ahead and create that file with me. Let's create a food key, which is where we'll have a list of food items and some basic nutritional information. We'll use an array of objects, and this first object will have an ID of 1, a name of apple. I'll set the calories to 88 based on a small 6-ounce apple. That size of a gala apple would be right around 88 calories. Copy and paste that same object 2 more times to save typing time. The second object will be for a chicken breast. So set the ID to 2, the name to chicken breast, the calories to 125, serving size will be 3 ounces. The last object will be whole milk. So increase the ID to 3, set the name to whole milk, set the calories to 240, serving size will be 8 ounces. I think this is a good starting point for our food database, at least for the purpose of this course. Next, we'll need a users database. We can add that to this file. Just create a new key below the food key called users. Again, this will be a list of objects. Add a single user for now with an ID of 1, a first name of Sam, and a last name of Davies. Also add an email key set to sam@acme.com. Let's go ahead and start the JSON server by opening up the terminal and running the command JSON server --watch db.json --port 3001 from the root of the project. If you are using npx, you'll need to run npx JSON server. Just put npx in front of the command. After a few seconds of waiting, your server should be up and running on port 3001. To test it out, you can visit one of the resource links in a browser, and you should see the JSON data that we entered in db.json. Now, I want to show you how we can iterate through our food options to get the one item our user entered and display the calories for that food, all using what we've learned about the symbol.iterator method. Back at our readline question of what would you like to log today, we can add some new logic here. We are going to want to make a GET request to our JSON server food resource. So let's install Axios with npm i-save Axios. Axios is a promise-based HTTP client that we'll be using to make RESTful requests to our JSON server. Now, I like using async await when working with asynchronous calls. So first, let's add the async keyword to this readline callback. Then you can await an Axios GET request to localhost 3001/food. Let's destructure the response to just get the data object, which will hold our array of food items. So remember, built-in iterables, like arrays, have the well-known symbol.iterator method available, and calling this method on the iterable returns an iterator. That iterator will have the next method, allowing us to step through each item. To see that in action, create a variable to hold the iterator called it, and create the iterator with data symbol.iterator. This creates an iterator for us to use. To start iteration, we need to call it.next, and we'll save that value to a variable called position. Remember that the value returned by calling it.next will be an object with a value property and a done property. Let's start a while loop that runs until done is true. Inside the loop, we can get the current object of the iterable with position.value, and let's save the name from that object to a variable. We will check to see if the name of the food matches what the user entered, and if they do match, we'll print to the terminal a message telling the user how many calories that food has. We need to update the position variable with the next item in the iterator by calling it.next again. Once the iterator is finished and position.done is true, we close the readline and end the program. To recap, what makes an object an iterable? Well, it can be enumerated with the for of loop. It also must adhere to the Iterable Interface, which means there is a symbol.iterator method on the object. The iterator returns a result that, at a minimum, must match an object with a value property and a done property. Other data can also be returned, but the built-in iterables will only return these two properties. Custom iterators have the ability to provide additional data that gets returned in a next iteration call. You can also have whatever logic you need to in your symbol.iterator method. In the next clip, we will start building our own custom iterators. And instead of only iteration through simple data, we'll look at how we can iterate through a list of functions. We've seen how we can use the built-in iterables to create iterators using the symbol.iterator method. Each time we've used the symbol, it was just with its execution. What I want to show you now is how we can define that method with our own custom logic. This means that we will define both the symbol.iterator and the next function that it returns. But for what purpose will we use this custom iterator in our console log my food app? Well, I've got a new feature request that fits perfectly within custom iteration practices. We need to add the ability to list foods that are more specific to dietary preferences. What I mean by more specific is for a user who follows a vegan diet, they would like to list out foods that are considered vegan. Or if they wanted to see foods that fit into the ketogenic or keto diet, they can list those as well. Unfortunately, we aren't able to change our REST API to filter foods, so we need to do it ourselves. Before we add this functionality, we need to make our command line tool a little more robust. We need the user to have the ability to enter different commands for logging food and listing foods, to name a few. To turn this app into more of a CLI, we can use the readline prompt and line event listener. Head over to your editor, and the first thing we'll do is add a new option to the create interface function. Enter prompt as the key and enter command > as the value. This means when we call prompt, the enter command string will print in the terminal. Go ahead and call readline prompt. Now we want to listen for user input. We do that with the line event listener. In the callback, add a switch statement which will control the functionality based on the user's command. Add a log case, then copy and paste our readline question into the case statement block. Instead of calling close here, change that to readline prompt so that we return to the prompt after they log their food. Let's add a new case here called list vegan foods. For now, just console log vegan food list. We still need to add more foods to our database and create our custom iterator. Rather than typing all of the vegan foods in this video, I've included a JSON file with these items in the project files for this course. You can grab those items and paste them into our db.json file before continuing. I've added a dietary preferences array to each food in our list. We'll use this to know what category each item belongs with. Now let's get started with our custom iterator. In our list vegan foods code block, create a new object called vegan iterable. Actually, we need to fetch the food from our API, so it makes more sense to define this iterator in the Axios promises resolve. So first make the same Axios get that we were calling earlier, and in the then method, let's create the vegan iterable object. This object needs the symbol.iterator method defined, and for it to be an iterable, it needs to return the iterator itself. The other method that is required is the next method. The next method needs to return an object with a value and a done property. We'll want to return each vegan food item one by one until there are no more items in the data array. But before we start filtering every non-vegan item out, let's just get the iterator working by returning all food items. In the next method, we want to get the current food item, so define a current variable to hold that. And we're going to need an index variable that we can increment. Let's put that at the top of this closure. IDX equals 0. Okay, so current will equal data IDX. Then we'll increment IDX on each next call. As long as current isn't undefined, we'll return an object where value equals current and done is false. If current is undefined, then there are no more items and we return value as current still, since it's undefined, and done as true. That's all we really need. To make sure we have a working custom iterator, we can run it through a for-of loop. I'll just let val of vegan iterable here and console log val.name to just print the name of the food. When it's finished iterating, we'll call readline prompt again to get us back to the prompt. It's time to test this out. Head back over to your terminal and run index.js. Enter list vegan foods at the prompt, and hopefully you see a list of our food objects logged to the screen. It looks like we have successfully created a custom iterator, but we aren't finished yet. We really want to print out only the vegan foods. Right now, all foods are being returned. So let's go back to the code editor and update our iteration logic. What I'll do here is filter out all of the foods that don't include vegan as a dietary preference. Create a new variable called vegan only and set that equal to the data filter function. We'll make sure to only include foods where vegan is included in the dietary preferences array. Now just update the current value in the next method to use our new filtered array, vegan only. Head back over to the terminal to test this out. Everything looks good. We are only seeing foods that would be considered vegan. I've actually added a few more items to the db.json file, like almond, lentils, and Oreos. These items should be in the course files, so grab them from there. At this point in our project, we are using a custom iterator to iterate through normal data. But data isn't the only thing we can iterate through. What if you had a sequence of methods? Could we use an iterator for that? The answer is yes. Yes, we can. Now that we know how to create a custom iterator, we should see what else we could do with it. Let's add to the log functionality of console log my food. I'd like to have a follow-up question if necessary. Sometimes people don't finish their entire serving. We want to adjust the calories when, for example, someone only eats half of a ribeye steak. This will give the user a better representation of what has actually been consumed. To make this work, we want to create a sequence of actions that will run when a user logs a food. We're going to do all of this with a custom iterator. Head over to the index.js file in your editor and go down to the log case. I'm going to do a little bit of a refactor here and move the Axios call outside of the readline question block. To continue using async await, we'll need to add the async keyword up here at the line event listener callback. Now we can await promises in here. Right now, this log method will still work exactly as it did before. Let's add a new custom iterator here called action iterator. We need to define the custom iteration logic within the symbol.iterator method. So let's create that first. We know we want to make this iterator an iterable, so we'll have to return a symbol.iterator method that will return itself. Now, how do we define a sequence of actions that we'll iterate through? To do that, we can create an array on this iterator to hold these actions. Let's call it actions. We'll populate this array with two functions, ask for serving size and display calories. In a moment, we'll define these functions. First, we need a place to store the current position in the sequence of actions. Define a variable called positions, and we'll just make a copy of the actions array by spreading the contents into a new array. Now, what should happen within the next method? We know we need a next method. We also know that it needs to return an object that follows the iterator result interface. To iterate through each action, we will want to call one of our functions in the action array, depending on what position we are in. That means we should modify the positions array on each next call by removing that function, then calling it. That way, when the following next call happens, it won't accidentally call the same function twice. Once all of the functions have been called, we will set done to true. So let's start defining the next method now. First, check the length of the positions array to make sure we aren't finished. If there are still functions to call, let's grab the next function in the sequence by calling shift. Shift will take the first element of an array out of positions and return it. Next, we'll just call position to execute the function. Since some of the next calls can have arguments, we'll need to pass those in as args to the next method. So just spread the args in the next method, then also spread them at the position call. We also want to return done as false, since we're not finished yet. If positions.length is 0, however, we'll want to return done as true, since there are no more actions to execute. That's pretty much all we need right now with this next method. Now we need to define our two actions. We'll start with the ask for serving size method. In this function, we need to prompt the user with a question asking them how many servings did they eat. We'll use readline question here and ask the question, how many servings did you eat? And in parentheses, I'm going to ask the user to enter this value as either an integer, like 1, or a decimal. This way we can use simple math to calculate how many calories they are logging. In the callback, we are going to call next on the action iterator, with the user input and the food object as the only two arguments. We'll get the food object when we first create the action iterator and call next for the first time. We'll pass the food object to next at that time. The second action is called display calories. This function will take two arguments, the serving size and the food object. Here we want to log to the screen the amount of calories associated with the chosen food. The sentence will read as, food A with a serving size of X has Y calories. Since the serving size can be a decimal, we'll need to make sure it gets parsed correctly as an integer. Serving size is also a string, so we will also need to parse that as an integer. Now we can call actionit.next again and return to the readline prompt. When calling actionit.next, done will be set to true, as there are no more actions to perform. To start this iterator, we need to create the action iterator when the user enters the food they are logging. Let's create a variable at the top of the log case called actionIt, which will hold the action iterator instance. Now, back in the what would you like to log today prompt, when we find the food that they entered, we want to create this iterator and call next for the first time. We'll assign the iterator to the actionIt variable that we just created. Call actionit.next and pass in position.value, which is the food object that we need in our actions. At this point, everything should be set up for testing. So head over to the terminal and start up console log my food. Type log, then enter a food like Oreos. Enter 2.5 as the serving size. And there's the message that we are expecting. Oreos with a serving size of 2.5 has 460 calories. Now you see how we can use a custom iterator to run through a sequence of functions. Next, we'll look at how we could have exited the action iterator early using the optional return method that can be defined on a custom iterator. So far, we've been going over creating a custom iterator and talking about what the object interface looks like. I thought it'd be a good time to look at what the official spec defines as the Iterator Interface. This is what we've been implementing with our custom interface. The next method must return an object that follows the Iterator Result interface. There's also these optional methods return and throw. Both of these return an iterator result, and typically you would set the done property to true, but that's not a hard requirement. Something you should remember is that most built-in iterators will not have these optional methods available. Arrays, maps, strings, sets, none of these have a return method or a throw method that you can call. Later, we will talk about what type of iterator will have these methods available. But for now, we will be implementing these methods ourselves on the action iterator. In this clip, I'll demonstrate the return method and the throw method, and how we can use them to exit the iteration process. We'll also start saving the food logging to the database, so that later we can display what has been logged. To see the return method in action, let's give our program the ability to exit based on the user input. How about when the user is asked about how many servings they've eaten, we allow the user to enter the word "never mind" if they would like to exit the question. Let's add some more logic to the ask for serving size function. We can check if the user has entered the word "never mind" or just the letter N, and if they did, we'll call actionit.return. All other cases will still call the normal actionit.next. For this to work, we will need to implement the return method on our action iterator. Define the return method right after the next method here. We want to make sure to empty the positions array, and then we can just return an object with the done property set to true. We are setting positions to an empty array just so that a rogue next call doesn't continue with the remaining functions, since remember, we do have a positions length check in the next method. We also need to change this const into a let. We might as well implement the throw method too. Now, according to the spec, this method does not necessarily need to throw an error exception. It can if you want it to, but it's not required. If you do not throw an exception, you do need to return an iterator result object, preferably with done set to true. Define the throw method below the return method here, and we're going to let it take one argument. This argument will be the error message that we will log to the terminal. We'll console log that message, then return an object with an undefined value and done set to true. Okay, so we have a custom iterator with a return and throw methods defined. We are logging food to the terminal with how many calories have been eaten. But we aren't saving that information yet. All we're doing is logging it. Well, let's update this functionality to actually save these logs for the user, so that later they can view what they've eaten. Head over to the display calories function. We're going to add an Axios put request here before we end the iterator. Since we're using JSON server as our database, posts and puts will actually update the db.json file for us with the request body. First, we'll need to fetch the user's log. We'll update that log with a new entry, then post that new log back to the user. Let's make this function an async function. Next, after the console log, add an axios.get for the user with an ID of 1. We'll get the data property from the response and assign the log to a new variable called user's log. Just in case the log is undefined, we'll set it to an empty array. Now we can create the request body, which will hold the rest of the user data along with the updated log. Spread the data object into a new object here, then add the log array and spread the current log first. Now for the log entry, we'll use an object with a key of the current date timestamp. The value will be an object with the name of the food, the serving size eaten, and the total calories. Now we can define the Axios put request to the same URL. Pass the put body object as the second param, and for the third parameter, we should make sure to add a header for content type and set that to application/JSON. Okay, let's test this out by opening up the terminal again and logging an apple this time. We'll do 2 servings. Now if we check the db.json file, we'll have a new entry into our food log for Sam Davies. Well, you made it through the first module of the course. Congratulations! We went over a lot of different topics that hopefully led to you having a better understanding of iterators and iterables. We defined what an iterator is, as well as what an iterable is, and what the difference is. We took a look at some of JavaScript's built-in iterables and worked through some examples. Then we built our own custom iterator into the console log my food application. And since return and throw aren't available on most built-in iterators, we implemented them from scratch onto our custom iterator. The type of iterator where return and throw are available is the topic of the next module, generators. So again, great work making it through this module, and next up we'll learn all about generator functions.